Welcome to this tutorial on using ROS2 with MATLAB and Simulink. Here's the learning path we'll be following throughout this tutorial. In this session, we will focus on another core concept of ROS2, the ROS2 service. Let's take a closer look at the detailed outline for today's session. What is ROS2 service? We'll begin by understanding what a ROS2 service is and its role in the ROS2 ecosystem. Service server and service client in MATLAB. We'll explore how to create and manage service server and service client using MATLAB, allowing you to send and receive data efficiently. Customize service definition. We'll discover how to tailor service definitions to meet specific application requirements. Service server and service client in Simulink. We'll then transition to Simulink, demonstrating how to set up service servers and service clients. Services enable node-to-node communication in a call and response model, differing from the publisher-subscriber pattern used by topics. While topics provide continuous data updates for subscribed nodes, services only respond to explicit client requests, offering data on demand. In this example, the service server provides a functionality named service to add two integers. The service client requests this operation by sending a message containing the two integers to the server. When the service server completes calculating the sum of the two integers, it sends a response message back to the service client containing the result. In ROS2, services are defined using a simple yet powerful data structure format known as .srv files. These files allow you to specify the structure of the data that will be exchanged between nodes. An .srv file consists of two fields: request data, the input sent by the client to the server; response data, the output returned by the server to the client. Each field can have specific data types, such as integers, floats, or strings. Additionally, you can define arrays or complex custom data types to meet the unique requirements of your application. This flexibility allows you to tailor .srv files to align with the precise data needs of your robotic system, ensuring efficient communication between nodes. Next, we will move on to creating ROS2 service server and service client in MATLAB. To begin with, we will demonstrate how to create a service server and service client in MATLAB to add two integers. First, we create two ROS2 nodes, one acting as the server and the other as the client. We create a service server by specifying the service name, service type, and a callback function. A ROS2 service server object will be created, complete with the associated QoS, quality of service settings. In this example, the callback function adds two 64-bit integers and returns their sum. When we list all available services, we can see the service we created, add two integers, along with its associated service definition. We can also examine the service definition in detail, including the structure of the request and response messages. Next, we create a ROS2 service client by specifying the service name and type. By waiting for the server's response, we can confirm that the client is successfully connected to the server. To request the service, we first create a message to initiate the request. In this example, we specify two integers, 1 and 2. Before calling the service, we can double-check the server's availability. Then we call the service by sending the request message, and we will receive a response message with the sum of 3. We can also call the service using only a default request message. We can obtain the status of the service request as well, indicating whether it was successful. Now let's move on to the second example, which uses Turtlesim to demonstrate how to create a service client in MATLAB for clearing, resetting, and spawning a turtle. First, launch the Turtlesim and the keyboard controller in the Ubuntu virtual machine. In MATLAB, create a ROS2 node to request services. When we list all the available services, we can identify the clear, reset, and spawn services along with their associated message types. While the turtle is moving, calling the clear service from MATLAB will clear the Turtlesim canvas. Similarly, calling the reset service from MATLAB while the turtle is moving will clear the Turtlesim canvas and reset the turtle to its original position and orientation. When attempting to call the spawn service with its associated message type, Turtlesim's spawn, an error will occur indicating that the message type is unrecognized. Upon listing all available message types in MATLAB, we find that the Turtlesim spawn message definition is absent from the list. We will address this issue in the next session. Next, we will move on to customizing service definitions in MATLAB. In the previous example, the Turtlesim spawn service definition was missing. In this example, we will demonstrate how to customize the service definition in MATLAB. First, we need to determine the definition of the message type. In the Ubuntu virtual machine, we will use the ROS2 interface command to display the details of the service definition. In MATLAB, within the custom folder and the Turtlesim folder, we add an SRV folder and create a spawn.srv file. We then open this file, paste the exact data definition, and save it. Next, we compile the custom messages. Once completed, we can see the generated packages. When listing all available message types in MATLAB, we can now find the Turtlesim spawn request and spawn response message types. We can also explore their definitions in detail. We are now ready to call the spawn service by creating a service client in MATLAB. By specifying the X and Y coordinates as 2 and 3 respectively, we can see a turtle has been spawned on the canvas. Additionally, we can add a name for the turtle in the request message. Next, we will move on to creating ROS 2 service server and service client in Simulink. In this example, we will explore how to create a service client in Simulink for Turtlesim. First, open the Simulink model and launch Turtlesim from the Ubuntu virtual machine. In Simulink, there is a publisher that sends commands to the turtle, making it move in a circular path. For the clear service, we use a trigger subsystem in Simulink to call the service. Within the subsystem, we have a message block to provide the service request message to the call service block. In each block, we select the appropriate service name, service type, and associated parameters. When we trigger the clear service by generating a rising signal from 0 to 1, we can see that the clear service has been applied. Similarly, we can call the reset service from Simulink. The last service we will demonstrate for Turtlesim is the spawn service. Like the previous service requests, we provide the X and Y positions to spawn a new turtle. Next, we will explore how to create a service server in Simulink to provide the service of adding two integers. In the Simulink model, there are three components: the receive service request block, the service implementation, in this case adding two integers, and the send service response block. In the receive service request block, we specify the service name, the service message type, and the paired send response block. The service implementation is an enabled subsystem. When a service request is received, the receive service request block generates an enable signal that triggers the computation within this subsystem. In MATLAB, we create a service client to call the service of adding two integers from Simulink. By creating a service client and a request message, we can call the service and display the result. When requesting the service from MATLAB, we can also observe the enable signal in Simulink, indicating that Simulink has received the service request. I hope you now have a clear understanding of ROS2 services and how to create service servers and clients in both MATLAB and Simulink. Thank you for participating in this session. In the next session, we will explore the ROS2 action. By the end of this session, you will have gained a thorough understanding of action servers and action clients in ROS2. I look forward to continuing our journey in the next session.